This is part 3 of the Annuities series. So in part 1 we've taken a look at the definition of annuity, how to calculate the present and future values of annuity and deferred annuities. Then in part 2 we took a look at perpetual annuities and what we refer to as an annuity due. And in this session we'll be looking at equivalent annuities and how to use annuities to compare projects. So first up we're going to take a look at equivalent annuities. So equivalent annuities is a term we use to calculate when we have different cash flows. So we've got $100 in year 1, and then we've got $150 for the next 3 years, and then back to $100. So an equivalent annuity is an important concept which calculates, so over these 6 years, what single cash flow, identical cash flow, could we have in year 1, 2, 3, 4, 5, 6 that represents this pattern of cash flows. So it's important that you can't just be like 150 times 3 plus 100 times 3 and divide by 6. It's not an average, because what we have to remember is that we've got the time value of money working here. So $1 today is worth more than $1 tomorrow because of interest. So what we have to do here is figure out here that what single identical cash flow over 6 periods is equal to this. So to calculate this, the most simplest way is to calculate the present value of the cash flow series, and then to rearrange the present value formula to determine A, and that's what we call an annual worth. So if we assume R of 10% for the above problem, what we've got is a single cash flow, bring back 1 period. We've then got a deferred annuity for 3 periods that we're going to have to bring back, or use method 2 as a 4 periods minus 1. And then we've got another deferred annuity up here. So if we go down, I've used the second formula where I do a normal annuity minus another annuity to figure out my thing. So we've got here the first $100 brought back 1 period. We've then got $150 deferred annuity. So I've assumed that it occurs for 4 periods and then minus that first period. And then we've got $100 deferred annuity, so I've assumed it occurs for 6 periods and then minus the 4 periods to get the deferred annuity. So then if we plug that all in, we get $548.56. Now that's the present value, so that's in year 0. Now what we have to do then is take this normal formula of present value and rearrange it. So we've got the present value, we've got 6 periods, so all we have to do is that divided by this whole thing, and we get an equivalent annuity of $126. And that's how we calculate what an equivalent annuity would be. So calculate first your present value and then calculate what A would be. Now this is an important concept when we're comparing projects. So in the most simplest form, we have projects with the same lives. Now what I mean by that is that every project has what we call a useful life. There's only a certain amount of years for which a project or a piece of equipment can be serviceable. So if we buy a truck, it may only last 20 years. So when we're evaluating whether to choose truck A or truck B, we have to take into account how long that truck is going to be useful to us, and therefore how long the expenses or the revenues are going to last for in comparison to the initial investment that we have to outlay. So in the case of two projects that we're comparing that have the same useful lives, we can use any what we call equivalent worth. So you can calculate the present value, you can calculate the future value, or you can calculate the equivalent annuity or the annual worth. And then what we do is choose the project that maximizes any of these measures. So if a project has a greater present worth or present value, then that's the project we're going to choose. But a problem occurs when you've got projects with different lives. So you can't simply just calculate the present worth, because on the first project it'll only be for 10 years and the second project will be for 20 years. So it's not a fair comparison. They have to be the same lifespans for present worth or future worth. But what we can do is, if we can assume the project can be repeated over and over again with identical cash flows, so if the first project is occurring only for 10 years, but then after the 10 years can be bought again for the same price and everything else can remain constant, what we can do is calculate the annual worth, and we then choose the project which maximizes the annual worth. So an important thing with this is that if we're going to answer a question, we're going to have to clearly state our assumptions. So this can only be used if the project can be repeated indefinitely. In most cases, we can make that assumption. In some cases, for something like IT, we probably can't, because chances are you're not going to be able to buy the same equipment for the same price. But in most cases, for trucks or any large investments, we could probably repeat the investment again, and therefore we can just choose the project which maximizes the annual worth. So that's it for this session. If we're going to look at some examples, take a look at part 4 of this. Thanks.